Yeehaw! We have made it to the last podcast for this unit. It's all about light equations, so get out your pencil and paper. We're going to be doing some math here. Might help you to have a calculator too. I want to review some equations for you. First equation tells us that c, which is the speed of light, is equal to the frequency, which is nu, times the wavelength, which is lambda. And remember that the speed of light is a constant. It's 3 times 10 to the 8th meters per second. So light travels at that speed in a vacuum. Right? 3 times 10 to the 8th meters per second. So that means if my frequency goes up, my wavelength has to go down, and vice versa. They are inversely proportional. You should understand that from math. Right? Energy is equal to Planck's constant times the frequency. Nu again is the frequency. Planck's constant is given to you as 6.626 times 10 to the minus 34th joule seconds, and energy is going to be in joules. Okay. And that means if the energy goes up, the frequency goes up. So these are directly proportional. So, how do I figure something out? Well, wavelength of red light is 6.54 times 10 to the minus 7th meters. What's the frequency of the light? Well, if I know that the speed of light is equal to the frequency times the wavelength, and I want to solve for frequency, then frequency is equal to the speed of light divided by the wavelength. Okay. So, that means, let's see, my frequency, which is nu, is equal to the speed of light, which is 3 times 10 to the 8th meters per second, and that's divided by my frequency, which is, divided by my wavelength, which is 6.54 times 10 to the minus 7th. Right? So what I do is I will take the 3 divided by 6, and I'll realize that's about 1/2. And I'll look at my 8th and my minus 7th, and remember when you're doing this, because this is division, you have to subtract the exponents. So 8 minus a minus 7 is the same as 8 plus 7, which is 15. So this is going to be about 0.5 times 10 to the 15th, which is going to be about 5 times 10. I made this number bigger, I have to make this number smaller, 14th cycles per second. Now, the first thing I want you to notice is that this is in meters per second, and your wavelength is in meters. So I have to make sure that my units match. Those are both meters. Okay. So my answer is going to be about 5 times 10 to the 14th. Well, if I plug the 3 divided by the 6.54 in, and I actually come up with a number, it's going to be 4.59 times 10 to the 14th. So I do this because I always estimate my answers first to make sure that what I come up with in my calculator is correct. Okay. So that's my answer. All right. Frequency of a particular light is 6.44 times 10 to the 14th cycles per second. What's the wavelength? Well, again, we have the speed of light is equal to the wavelength times the frequency, and I want to come up with the wavelength. So the wavelength is going to be equal to the speed of light divided by the frequency. Okay, so my wavelength is going to be the speed of light, which is 3 times 10 to the 8th meters per second, divided by 6.44 times 10 to the 14th cycles per second. Right. Well, if I look at my units here, I've got seconds on the bottom here and seconds on the bottom here, so they're going to cancel. So I'll be left with meters per cycle, which certainly sounds like wavelength to me. And I'm going to get, let's say, again, I'm going to estimate first, 3 divided by 6 is about 1/2, so that's 0.5. And the 8 minus the 14, well, 8 minus 14 is going to be a minus 6 times 10 to the minus 6th, which means this is going to be 5 times 10. I made that number bigger. Got to make that one smaller. So it's about 5 times 10 to the minus 7th, and it's going to be meters, okay, because it's meters per cycle. Notice my units here are meters. All right, so let's actually plug this into a calculator. When I plug this into a calculator, I get 4.66 times 10 to the minus 7th meters, which is real close to the answer that I got here, so I can believe that that is right. Okay. problem is when we do this, we tend to measure wavelength in nanometers. Now, so far we've done everything in meters, but we talked in previous podcasts about the wavelength of visible light being 400 to 700 nanometers. So how do I do that? Right. So that's the same as 4.00 times 10 to the minus 7th meters and 7.50 times 10 to the minus 7th meters. But gosh darn, what do we do there? Well, I'll tell you. The speed of light is 3 times 10 to the 8th meters per second. Meters per second. So maybe if I came up with the speed of light in nanometers per second, that might help. Well, 3 times 10 to the 8th, that's an 8, stop that, meters per second. And if I do my dimensional analysis, seconds is right, but I don't want meters, I want nanometers. And I know that there are a billion, or 10 to the 9th, nanometers in 1 meter. And my seconds are going to remain, so I've canceled my meters. So now I have nanometers per second. And I have the 8 and I have the 9, and I have to add those together. So I get 3 times 10 to the 17th nanometers per second is the speed of light. Okay? Well, that's going to help me whenever I'm working in nanometers. So if my problem is given to me in meters, I can use this, 3 times 10 to the 8th meters per second. If my problem is given to me in nanometers, I can use 3 times 10 to the 17th nanometers per second. Okay? Now, if I'm given frequency, and asks me what's the wavelength, I can get my wavelength in either meters or nanometers, it doesn't matter. Okay? You just have to choose which one you're going to use. All right. So let's say that my wavelength is 733 nanometers, and I have to calculate my frequency. Well, again, my speed of light is equal to my frequency times my wavelength, and if I want my frequency is going to be my speed of light divided by my wavelength. So my frequency is equal to the speed of light over wavelength. I know that the wavelength is 733, and notice this is nanometers. So if I go 3 times 10 to the 7th, 3 times 10 to the 8th up here meters per second, that's not what I want. I want nanometers per second because I want to be able to divide the nanometers by nanometers to get rid of them. So that would be 3 times 10 to the 17th. 17th, skip, right, 3 times 10 to the 17th. So now if I take 3 times 10 to the 17th divided by 733, well, I'll tell you what I do. I do that as 3,000 times 10 to the 14th. Divided by 733. So my answer is going to be something times 10 to the 14th. Now let's see, how many times is 733 going to 3,000? Probably about 4. So my answer is going to be about 4 times 10 to the 14th. So now if I plug this into a calculator to actually see what answer I get, the answer that I get is 4.09. Try that again. 4.09 times 10 to the 14th. And my nanometers cancel, so I'm left with this is cycles per second. Okay, and that's it. Okay. How about this example? Calculate the wavelength of light where my frequency is 5.21 times 10 to the 14th cycles per second. Now, I'm going to choose to do this in nanometers. I'll tell you that right now. So why don't you pause the video, see if you can do it, and then come back, we'll do it together. Okay. I'm starting with 5.21 times 10 to the 14th cycles per second. Right? Now, how in the world do I do this? Well, remember, speed of light is equal to wavelength times frequency. So I'm trying to calculate wavelength. So that's equal to speed of light over frequency. All right. So if I divide this, that's frequency. So I'm going to put 3 times 10 to the, well, if I use 10 to the 8th, I'm going to get meters. And I'm deciding I want to do nanometers. That's 3 times 10 to the 17th nanometers per cycle. So, nanometers per second, excuse me. The seconds cancel, so I'm left with nanometers per cycle. And if I divide this, again, that's about 3,000 times 10 to the 14th divided by 5. Let's see. So 3 times 10 to the 17th divided by 5.21 times 10 to the 14th. The beauty of these is, remember, these subtract from each other. So this is really 3 times 10 to the 3rd divided by 5.21. Right? And 3 times 10 to the 3rd divided by 5.21 is going to give me 576. Okay, and this is in, notice this is in nanometers up here. Wavelength is going to be in nanometers. Okay. How about a wavelength of 250 nanometers? What's its frequency? Again, pause the video, try it, see what you come up with. All right, speed of light is equal to frequency times wavelength. And I want frequency, so that's equal to speed of light divided by wavelength. Notice I'm given nanometers, so I'm going to use 3 times 10 to the 17th nanometers per second for my speed of light. And I'm going to divide that by 250. If that's in nanometers, my nanometers are going to cancel. I'm going to be left with per seconds, which is cycles per second. Which, when I do the math here, that is going to give me 1.17 times 10 to the 15th cycles per second. Okay, let's try another one. Right, again, pause the video, see if you can do it. Speed of light is equal to the frequency times the wavelength. I want the wavelength all by itself, so it's speed of light divided by frequency. So when I come up with wavelength, I'm going to choose to do it in nanometers because I tend to like nanometers. So the wavelength is equal to the speed of light, which is 3 times 10 to the 17th nanometers per second. And my frequency is 5.30 times 10 to the 15th cycles per second. My per seconds cancel, so I'm going to be left with nanometers, which is wavelength. So I've got 3 times 10 to the second divided by 5.30. And again, that's just me. That's the way I tend to do this. And that comes to be 56.6 nanometers. Okay. Here's something that's new. We have to go back and say, well, energy is equal to Planck's constant times my frequency. And I know that Planck's constant is equal to 6.626 times 10 to the minus 34th joule seconds. All right, you should have seen that. You should have seen that in earlier, written it down. Hopefully that was Planck's constant. So I'm trying to figure out energy, and I'm given frequency, and I'm given h. So all I have to do is multiply them together. So if I multiply those two things together, that's pretty easy. And my answer is going to be 3.25 times 10 to the minus 19th. And my energy is in joules. Okay. All right, let's try this one. Energy is, no, it's not joules seconds, it's just joules. Energy is 6.6 times 10 to the minus 19th joules. What's the frequency? Well, again, energy is equal to Planck's constant times frequency. I'm trying to get frequency all alone, so frequency is equal to energy divided by h. Okay, so that is equal to 6.60 times 10 to the minus 19th divided by 6.626 times 10 to the minus 34th. Now remember, this is going to be minus 19 minus a minus 34, which is going to give me a positive number. It's going to give me about times 10 to the 14th. So my answer here, if I actually go in and do the work, it's going to be 9.96 times 10 to the 14th. And this is in cycles per second because this is frequency. All right, here's my last one. What's my energy? Well, this one's going to take a little bit more work. See if you can do it. And if you can't, go ahead and keep watching. All right, energy is equal to Planck's constant times frequency. I'm trying to solve for energy, but I don't know frequency. And if you remember, we have speed of light is equal to frequency times wavelength. I do have wavelength. So frequency is equal to speed of light. Come on, talk to me. Speed of light divided by wavelength. So I have to plug that in over here. So I get energy is equal to h times the speed of light divided by wavelength. Now, pause the video if you can plug in. You should be able to plug in now. Alright, so this becomes 6.626 times 10 to the minus 34th joule seconds. And I'm multiplying by the speed of light, which is 3 times 10. And this is in nanometers, so I want to use my nanometers number. 3 times 3 times 10 to the 17th nanometers per second. And I want to divide this by my wavelength, which is 645 nanometers. All right, so my nanometers are going to cancel. My seconds to my per seconds are going to cancel. I'm going to be left with joules, which is energy, so that makes perfect sense. And I take the 6.26 times 10 to the minus 34th, multiplied by 3 times 10 to the 17th, divide by 645, and my answer, when all is said and done, is 3.04 times 10 to the minus 19th, and my units are in joules. All right, folks, that's it. Those are some examples. Please go off and do the worksheet. You need to know how to be able to convert between frequency, wavelength, and energy. Be very careful to watch your units, especially the meters and nanometers, because that's something that we do a lot. Okay? If you have questions, I'll see you in class. Have a great day, and congratulations for finishing this unit. Bye-bye.